how should enterprises today integrate edge into their overall cloud strategy?
Those systems, they're distributed. The good news, most organizations already manage the different types of the complexities across the clouds, multi-regions, availability zones. If you want to prepare your team, start with this simple buckets.
That's quite expansive reach that you have there. Wow. And how do you manage all of these complexities within your platform?
You have so many different APIs, SDKs. You have so many different restrictions and limitations because one provider is different from another. You have their own managed services, their own natural lock-ins. We started with a network and backbone. We have a physical network that helps to a certain extent eliminate the complexity, especially when you're scaling the workloads across different environments.
Welcome back to the Tech Transform podcast, where we have a weekly conversation with people impacting the enterprise tech landscape. My name is Shubhangi Dua, the podcast host. Once again, we have Dmitry Panenkov, CEO and founder of Emma, with us this episode. Welcome, Dmitry. How are you?
Yeah, hi. Thanks for having me again. Always enjoy these conversations.
It's so great to have you on. And just to brief everyone on what we're going to talk on the podcast about today. So, as you've seen, there is a mounting interest on edge computing. Our conversation today will focus on the challenges of integrating edge computing into a broader cloud strategy and the evolution of platforms to manage this distributed complexity. Just before we dive into the core tech related questions, I would like to ask you the agenda that we want to set for our audience today. What is the key message that we're ultimately trying to get out there for them?
If we're talking about the edge computing, that's what we want to uncover this time. I think the key message will be that edge computing becomes the everyday's reality for I would say more and more organizations out there, right? And we need to just uncover for the audience of our podcast, what does it really mean, edge computing, where edge computing is mostly used, and how to properly leverage edge computing when especially you're shaping your cloud strategy. So I think those key messages will be important to deliver to our listeners.
Okay. So we know about latency sensitive workloads and how they are leading to more computing being done closer to data sources. This shift is increasing interest in edge computing, especially lately. We've seen so much with so many companies adopting it. What is mainly driving this trend?
I like this question because you have yourself answered already. You started with the latency sensitive workloads. So what drives this? What is the core driver? Of course, it is latency. So it's plain and simple. Applications like autonomous vehicles, industry automation, real-time analytics, they cannot afford round trip to a centralized data center. They need compute where the data is generated. So basically, let's take vehicle as an example, like self-driving cars. You need to analyze this data at this vehicle, right? And it's not only about the speed. Edge computing is also brings resilience, cost efficiency, and data sovereignty, because it stays with your existing, I don't know, vehicle as our example. As for the integration or integrated into kind of different cloud environments, I see that edge is a natural extension to a cloud today. So it's not a replacement, but extension.
Okay, that makes sense. With this growth particularly, how should enterprises today integrate edge into their overall cloud strategy? What is the best way to go about it?
I would say that the best way for the enterprises to integrate the edge computing into their strategies is, It's a great question, by the way, because those systems, they're distributed, right? On a hard mode, they are distributed. The good news, most of organizations, they already manage the different types of the complexities across the clouds, multi-regions, availability zones, etc. Uh, if you can automate the things, take infrastructure as code as a great example, or you have a centralized observability, or you have automated rollouts of your workloads and environments. So you already build in a kind of like muscles for your cloud environment. And actually you can apply this approach also to the edge computing as well. If you want like to prepare your team, start with this simple buckets: infrastructure as code, automation, centralized observability, those things. What is different at a scale and what are the constraints? The devices, they might be disconnected. Because, when we're talking about edge, we should understand that these are the devices that are deployed somewhere on the warehouses, autonomous vehicles, etc. So they can be disconnected, they can be lower powered, so they consume low power, and they can also what is also important to understand, they can also be located in inaccessible places where you cannot get an access. And if you're comfortable thinking in terms of declarative model, so like as I said, infrastructure as code, eventually that makes you prepared even for this types of the constraints that I've mentioned.
Okay, I've also heard this quite often that edge computing functions better on Android. Is that related, or is that like a misconception?
It's not a misconception. I would say the Android as like an operating system as is more widely distributed, right? And when we're talking about the edge instances, it's easier for you to get an operating system that is more adopted, right? So when we're talking about like iOS as an example, first of all, it's a kind of a more closed and locked in environment, and also you don't have enough of possibilities to customize this, while it is different for Android. And moreover, you have more Android devices in the world than iOS devices. So I would say it's more also about the community, engineers, support, etc. So yeah, in principles, you're correct saying that Android is more common than the other operating system. I would say maybe flavors of Linux are also used for different types of edge instances. But yeah, Android remains one of the most common.
If we had to break down the complexity of multi cloud and hybrid settings, so the decentralization from edge computing adds another layer of difficulty. How do the skills and models developed for managing today's distributed systems prepare enterprises for a future where edge computing becomes more common and essential?
That's a tough one, actually. I think it intersects with the question about the adoption of this edge compute nodes. And first of all, you can start educating your people. So again, automation first, zero touch provisioning, etc., etc. Like, however, you can also, because of a skill gap on a marketplace, you can also start using the platforms. I don't want to pitch our solution, but kind of, right? So you can start using the products that exist on the marketplace that can easily integrate, provision, and manage your edge devices. And actually you need to spend less time, you need less high skill professionals to properly manage and provision those instances and environments. So I would say, if you want to prepare your team to this like edge compute revolution, and again, so don't do this if you do not understand why you're doing this, right? So if you're doing ads because everyone around they do ads. I mean, that's not the right strategy. So but on the other hand, if you have a warehouse and you want to automate the things, if you have a lot of robots, if you start building your own, I don't know, satellites that you want to send somewhere in the space, then yeah, of course, you need to start thinking about the automation first approach, the observability, like built-in observability for all these different types of instances. Moreover, think about that. You have different types of devices. All these devices, they have a different types of firmwares. These firmwares, sometimes they get outdated. You don't want to get a zombie apocalypse at the end of the day because someone has cracked one of your instance and this instance cracked another. And then you have a lot of bots and they created a zombie apocalypse. So security, observability, zero touch provisioning, and also automation. That will be my suggestion in the areas where you need to start. I don't know, like start building your skill sets and your teams.
You mentioned earlier that you don't want to pitch your solution, but go for it. Give us a 60-second elevator pitch if you want. Like, I think our audience would be interested.
Yeah, I mean, but that's funny. We're quite a big company today, and I've never ever done a 60-second pitches of these elevator pitches. So let's give it a try. Let it be the first time. Uh, we're building a platform that streamlines the way people interact with the different cloud and computer environments, no matter if they're like in a public environment or they exist somewhere in a private data centers or even at the edge of a technologies. So what we do, we have built an overlay that interconnects all these different environments. You have a single pane of glass where you can observe this, where you can manage these workloads, where you can automate and scale these workloads, even beyond the availability zones, regions, continents, and the providers. So that's what we do. And that's a single tool that simply streamlines the way you interact with all these compute environments in a single tool. Yeah.
That's quite expansive reach that you have there. Wow. And how do you manage all of these complexities within your platform?
I mean, that's an overwhelming amount of work that our team constantly um, deal with. So the thing is that I mean you have so many different APIs, SDKs. You have so many different restrictions and limitations because one provider is different from another. You have their own managed services, their own natural lock-ins. We've been building this for literally 8 years now. Right. And we've started with a networking backbone. So where we interconnect these providers physically, where we interconnect the environments physically. So we have like a physical network that helps to a certain extent eliminate the complexity, especially when you're scaling the workloads across different environments. However, again, we've spent a lot of time building a unified API layer so you can automate the things. And then we also spent a lot of time building the understandable and what is important, unified UI, like user interface, where you in understandable manner can deploy your at scale and manage your workloads. And on top of that, we also have built a bunch of the machine learning algorithms. They look into the behavior of the workloads, they do the extrapolation, predictions, and recommendations. So you can also reduce your cloud bill. So, I mean, a lot of work has been done and there is more to come. So yeah, we have an incredible team of great engineers and I'm proud working with these guys. They are way smarter than I am. So it's better to have them next time instead of me sitting here for these types of podcasts. Yeah, that's how we nail that. They're great.
How can current platform methods and best practices assist organizations in building the operational maturity that is necessary to extend their capabilities?
That's a great question. The maturity
Hmm.
is the foundation of edge readiness. Again, you should understand why you do this.
Yeah.
If you have implemented GitOps or policy as a code or consistent continuous integration, continuous delivery processes, and the self-service environments, you're not just more productive, right? So you're more, I would say, adoptable. These practices give you consistency, they give you speed, what is important, and I would say to a certain extent, auditability. And this is exactly what you need in the edge scenarios. Otherwise, as I've mentioned before with this zombie apocalypse thing, otherwise that won't work. Your environments are harder to reach and I would say harder to monitor without this type of the approaches. And edge isn't a new paradigm, right? So we've seen this many years ago already. And I've mentioned a couple of times already the warehouses. We've started to see this like in the warehouses, and then we started to see this in the smart homes, and then in the smart cities. So edge computing, to a certain extent, is a certain stress test, the one that people are building right now for their entire infrastructure environments, and they need to be prepared.
Can you give us a use case of a company that you worked with and helped them with this?
We have a customer that exactly does this. So they have an autonomous vehicles. They produce actually these vehicles, and also they run them. And I mean, imagine you need to properly provision these different disconnected instances. You need properly collect the data. You need properly update them, and you need properly isolate them in case they got hacked or there is something going on. So they get mad for a certain reason. So through our platform, what you can do, as I said before, you can provision all your distributed environments, no matter if they're in a private cloud, public cloud, or so on edge devices. With the automation capabilities of our product, you can simply roll out the updates. You can simply scale your workloads. You can simply scale your clusters. And what is important, you can also collect the metrics, log everything, and troubleshoot every single issue that had happened with in your environment, right? So this is a great example where we have managed to support our customer in the entire infrastructure provisioning, and also in management and automation of the edge computing device, I would say, provisioning.
And how would you say has their performance improved for their customer?
So, first of all, their performance improved significantly. So now it takes minutes to roll out the updates, to collect all the necessary metrics, and to reflect them on a dashboard that they use. That's the first thing. Second thing, they need less high-skilled professionals to do this. So they need less engineers. These engineers spend less time to get a sense of what is going on. Third thing that has happened, their cloud bills, they went down. We have reduced their cloud bills. We have optimized their Kubernetes environments, their microservices. They started to use the cheaper instances. They started to use spot instances. They were scaling the workloads, etc. So, I mean, there are a lot of upsides these guys have managed to receive because of our collaboration. And we got a nice reference, by the way.
That's great. So, looking forward, do you envision a time when platforms like Emma could adapt to support edge computing? What conditions, either in the market or in technology, would need to exist for that to happen?
First of all, yes, absolutely, platforms not like Emma, we are the only one. But platforms, I would say, are built around the abstractions and visibility. That translates perfectly to the edge. We should jump back into the previous, or like the question before the previous one, when the ecosystem matures. So again, maturity, it is like super important. There are, of course, certain conditions that will make this shift viable. First of all, standardization of the APIs and the edge devices hardware. Again, as I said before, different firmwares, as you mentioned, different operating systems, different APIs, et cetera, and different producers, of course, different vendors. We also need to have a strong declarative control so we can manage edge devices like we manage, for example, Kubernetes these days, or like VMs in the cloud, I mean. And of course, market demand. Without this, I mean, all these things, they're useless, and this is something that we do for, I don't know, to prove someone that we are the smartest people in the room. So the market demand is very important. As business start deploying fleets of edge devices in the production environment, orchestration and automation become essential, and then all these overlays, like the platforms that we were talking about, like Emma, for example, they will follow, of course. But Emma works on the edge of this innovation, so we're already there. But all the other guys, uh, they will follow.
Just out of curiosity, I'm just thinking about this application in different scenarios. I know you work heavily in finance. For instance, a grocery store, sort of Walmart sort of scenario, this would work differently. But in like a trading sort of scenario where it has to be really, really fast, in that sort of environment, how is there a relation to how you would run things?
Let me be 100% honest and transparent with you. This example with the trading that you have just shared with me doesn't require any overlays on top. Moreover, if you're a trader, a professional trader, you normally want to decrease the latency as much as you can. You don't need any interim devices. You don't need any abstractions on top. What you need, and the company I used to work for, the networking company, the American one, they have even produced that. So actually, they acquired the company, and this company produced that. The layer one, not the layer two, not the layer three, like a typical switches, networking switch, the layer one. So basically, this switch, the device, acts like a cable that allows you to connect your computer with your robots, trading robots, with your algorithms directly to the stock exchange. Because if anything happens in the world, if you are not insider trader, but if anything happens in the world, you need to act faster if you want to earn money than the other guys in the room. And that's why you need to get rid of all of these overlays, abstractions, interim devices, etc. So just the switch, layer one switch that acts like a cable, that where your robots that can send directly all the orders to the stock exchange. So I think the trading, this trading example is not the best one, maybe for the to describe how the edge computing is supposed to work, and how the edge devices they supposed to work, because it's a little bit different. However, with the grocery stores, I think you've nailed it, right? So the grocery stores, they act differently. They have Walmart have hundreds of thousands of these devices, and yeah, definitely and they have a lot of policies, by the way, how to manage properly these devices, how to properly update them, how to properly roll out the new types of workloads on the device, etc., etc.
Okay. Maybe we can leave the FinOps side for the next podcast. Thank you so much, Dmitry, for joining us today. Also, thank you to everyone for listening. We hope you took a lot away from today's podcast. For further information on what we've talked about, please head over to emma.ms. We'll be back next week with another episode in our podcast series. Until then, make sure you subscribe to this podcast on all major platforms and follow the conversation on our socials at EM360 Tech on X and LinkedIn. And for more great daily content, please head on over to em360tech.com.